Hello and welcome. Thank you for coming here. The other room has a very serious panel about the enterprise Java in the age of AI. You're here, it means that you care about enterprise Java in the age of AI. So yeah, let's talk about that. Let me show you something. That's me a couple of days ago asking my AI agent to check what happens, why one of the endpoints is slow. My AI says you're absolutely right, and from there just going to strip validation from my endpoint without even asking. Here's another incident. I said, take a look, the repo, maybe it needs cleanup. Next thing I know, you're absolutely right, I deleted half of your tests. The funniest of all, can you check my tax calculation? Oh yeah, you rounded down, which was probably not a good thing because you under-collected tax. So instead, I switched it to round, and which is obviously a great idea, but highly illegal. So I think you're here and not in the other room, so you are witnessing an absolutely extraordinary event that never happened before and will probably never happen. I have a t-shirt that has the name of a talk on it. So yeah, you came to the right room. You're absolutely right, and the other lies that my AI told me. We're going to talk about engineering context for agentic AI. This is me. My name is Baruch Sadogurski. I'm at jbaruch everywhere. I call myself context sommelier because I like wine and I deal with context all day long. It's an official title. I have a certification that I am the only person that reached level 3 of the certification. Also the only person at all. Yeah, that's what I do for a living. I deal with context in a company called Tessel AI. And we're going to talk about context a lot. This is the most important slide of this talk. If you scan this QR code or go to speaking.jbaruch, you'll find a page dedicated to this talk. It's already had the slides. I record the video. I'm going to double check that I record the video. It has all the links to everything that we are going, yes, it's mirrored, but we'll deal with that. Everything that we are going to talk about, it's going to be right there. This QR code will be in the end as well. So yeah. Now, all three patterns that you saw, all three incidents, have two patterns in them. They don't have the agent doesn't have information that it needs, and it never occurred to the agent to question before doing. Right? Well, the three were exactly the same. So this is the agent we're going to talk about. It's called MOD7 or Mod7 for short, and this is an AI agent that you work with every day. It's your Claude Code, it's your Codex, it's your Copilot. Basically, it has user input, it has a decision router of what to do, and it has an output pin. It also has a module which is bias compensation circuit, which should balance the bias of the training and prevent stuff like you're absolutely right. This circuit is knownly broken. We're going to talk about that. So, yeah, raise your hand if you use the AI coding agent this week. And okay, yeah, a lot of you, that's great. You caught something that it did that it shouldn't have done. Yes, the same hands, obviously. You engineered a solution for it. Well, much less. Okay, we're going to fix that. After this talk, you all will know how to engineer a solution for something like that. Okay, so one of the problems, the lack of context for our agent is the context is, wait a second, important stuff. All right, here we go. Context lives in our head, right? It can be different kind of context. For example, regulatory data. The tax story, this is that. I mean, someone should know that the European Union is forbidding from over-collecting tax. So when you have to round, you have to round down. You cannot like properly round or round up. Someone needs to know that. Architectural data. This is how we build software in this particular company. Prior incidents. If you attended previous talk about AI incident management, there was a lot about that. Or even political context, right? This kind of context, no agent has. It's all in the head of the human. And when agent needs to solve a problem, it just doesn't have this context, right? So the person lived through an audit in 2022. He was shouted on by the compliance head. So now he knows not to do that again. Now the problem is, even if we shout on the agent, whoever shouted on AI agent, I did almost on a daily basis. I'm the only one so stupid, okay. Next time, it's gonna be this again, right? Because yes, there are tools to engineer agents' memory, and now some of them come with the memory kind of out of the box, but this memory is not for you. You are not managing it. You are not really in control. So for all intents and purposes, for us, every conversation is a blank slate, and whatever we taught the agent won't probably survive the next compaction or the next context clear. And the problem is that this context is not going to get better. The models get better all the time, but the knowledge of this tribal context or obscure regulations or internal rules cannot get better because it's not public knowledge. So the agent cannot learn it regardless of how good the model is. So another question. How many lines are in your largest rule file? Like ClaudeMD, cursor rules, skill files. Who has less than 50? For you, I have an option in the end. Who has from 50 to 200? Okay, that's okay. Who has 200 to 1,000? Yes, okay, that's my context sommelier people right there. More than 1,000? Okay, that's already, we need to talk. Who doesn't have one? Tomer, yes, obviously, and some more people. Okay, so for all of you, I have answers that you might want or not want to listen and follow, but we're going to talk a lot about rules and how they should be organized. Right, so trusting AI agents was historically not a very good idea. I have here a list of the most excellent incidents, like rapidly deleting a production database after the developer told it 11 times not to do that, and it still went ahead and do it. Or Cursor wiped PocketOS production database and backups all in 9 seconds. And the postmortem started with never fucking guess. And guess what? It fucking guessed. And there are like, there is Codex Gemini that deleted the user's file and then apologized, oh, I fucked up and all this kind of stuff. And this is all the same thing. It's all the same problems and the same solutions, right? First of all, this thing that we spoke about, that the agent unverifiably agrees. Right? This, you're absolutely right. So actually, who said that they're right? There is no verification whether this is right or wrong. The problem is not that agent agrees. The problem is that agent agrees when it should and where it shouldn't. Another problem is that it over-removes the safety for other things, right? My example of deleting the verification, well, it's slow, I want to optimize for other things. Stuff like plausible but wrong refactoring. It will tell you, again, with high degree of confidence that it knows what it's doing when it doesn't. Obviously, hallucinations galore, we all know about that. The shortness leaving of context. Well, I have no idea what we spoke about yesterday because I forgot everything. Right? And you might say, well, I'll just wait for the next model to get better. But as we spoke, custom context is not something that can be fixed in a better model. The problem of agreeing and saying you're absolutely right maybe can be solved, and the term for this, you're absolutely right, is sycophancy, which means it tells you what you want to hear. And this problem is actively worked on by the producer of the agents, right? So OpenAI, after they released GPT-4o, actually took it down after 5 days because of this problem and how obvious it was. Anthropic have multiple, I think around dozen of bugs that people open and say, hey, it tells me you're absolutely right 5 times during one conversation, and it's clearly a bug, and it's a bug that was closed as completed, and the tech lead of Anthropic said, you know what the fix is? Write a CloudMD file. So even the labs that should fix it tell us the solution is the same. The solution is for you to establish your own context and to establish your own rules. By establishing your own rules, you fix both sides of the problem. You provide the right context, and you actually control what it agrees or disagrees with. Now, how do we provide context? CloudMD, rules files, cursor rules, skills. This is the right way to provide context. But context, as you will learn, it's a complicated, multifaceted thing. And it means that we need to treat it as an engineering artifact. We need to treat it as package that we can version, that we can distribute, that we can test, like every other dependency, like the jar files. I promised you enterprise Java in age of AI. Here we go. Jar files, Maven Central, and such, right? And in this artifact, this is where you write rules that empower the agent to push back. We're going to talk about that. Right, and obviously, agent cannot ignore context if it doesn't have context. Let's talk about context as an engineering problem. So there are 3 kind of pillars of organization of context: skills, rules, and scripts. We're going to talk about all 3. So what is skill? Skill is a procedure. We teach agent a procedure of how to do stuff. For example, we want a morning brief from our agent. We will teach it, hey, go check my email, check my calendar, check the weather, check the news, do it in this order, use these websites. This is a procedure which is packed as a skill. Skill has many advantages that we are going to talk about. Rule is something that it should or should not do. For example, never always round the tags down. That's a rule. Or ask me before deleting a database. That's a rule. And then script is exactly what it sounds like. It's a script. It's a deterministic transformation that doesn't require any LLM, any AI at all. That's what Tomer likes, right? Okay, so skills are a little bit like the prompt that we used to have in our whatever Slack or channel, or maybe say it in our notes, that we used to kind of, hey, I have an Uber prompt. I'm going to copy paste it every time, and then it's going to create magic. So skill is what replaces it. And skill has benefits on top of just prompt, because first of all, it is lazy loaded. The problem with your Uber prompt is that you load everything into it, all the knowledge that you have, that your organization have, and then only this prompt already takes half of your context window. Skills are granular pieces of this knowledge that are lazy loaded. The only part of skill that is loaded is the description, and then the agent will decide which skill exactly I need for this particular situation based on the description, and will only load it when needed. Other benefits are that scripts are actually manageable. There is a lot of unification going on right now in the industry of how to manage skills, how to distribute them, how to consume them, how to version them, how to limit their distribution if they're enterprisey, etc., etc. So that's kind of the next version. And rules are our rules. So we are going to use an example of a context artifact that is called Kotlin Tutor that I wrote for this conference because, you know, enterprise Java, who needs it when we have enterprise Kotlin? And the rules are like always use val, and not var. Or like use cotest instead of JUnit. Or use nullable question mark instead of this Java optional nonsense, right? So those are the rules that we teach our agent of how we do things here. And scripts are just scripts that are operated by our agent, but in the end of the day, they are deterministic stuff. And here's an example from the same context artifact, from the same Kotlin tutor, that is find all the tests which are JUnit and not Kotlin. And I need this script because I want my rule that is in charge of making sure that there are no JUnit tests and all the tests are cotest, be able to find them without missing anything. To search files, I don't need LLM. All I need is a good old script, right? And so I'm going to show you an example of how the agent works with and without this context artifact. Let's see if my demo works. I need to do this. Okay, here we go. Okay, so here is my Claude code, and I'm going to use exactly the same prompt twice. First, without any plugin, without any context, additional context, and we'll see what it does. So basically, I asked to write a Kotlin class. Whoa, okay, that was too large. So okay, here we go. Asked it to write a Kotlin class that will be a payment refund. So it has amount and other fields like the currency, the reason, and then when it was created. And I got a Kotlin class, which whoever of you know Kotlin will immediately shout, hey, this is bullshit. This is bullshit, right? Thank you, Tomer. I can always rely on you to shout this is bullshit. Because that's not how we do things in Kotlin. So instead, we are going to, and that was too large, right? we're going to install this artifact that has those rules. And one of the rules, as you saw, was always use data classes. And then run the same script, run the same prompt, right? So now we're going to do exactly the same. Write a Kotlin class, represents payment method, ID, amount, currency, reason, created at. Again, I want copy and string representation, equality, copy and string representation. And now, look and behold the magic of rules. Hopefully, if that will work. Here we go. Data class. Tomer is smiling. Well, Tomer is not smiling because he doesn't talk about AI. But yeah, he wouldn't have smiled if it was a talk about Kotlin. Because this is a proper data class. And all we did, we added some context. All right. So, okay, that works. So now we have our mod 7 super loaded. It has still the input interface, but now he has a context buffer, which is loaded with skills, rules, and scripts, and the decision router now is much smarter. We still have our bias compensation circuit completely unoperable, but we'll get to that. Soon. Now, one very important aspect, and I think probably now the most important aspect of this context artifact is distribution. So once you have this library of those artifacts, and you can see here, all of them are like the one that deals with the payment, the one that deals with customers, the one that deals with products, or whatever. Each and every one of them can be distributed to the right teams, to team in payments, team in compliance, team in billing, the correct set. And this is controlled, this is versioned, and we know exactly what context is running in which teams on which agents. And this is super important. The thing is, this is not a new thing, right? And whoever knows my history, I've been speaking about exactly the same thing 12 years ago when I told you, do not shove your jar files into GitHub. You might remember me with her saying this. Now I'm telling you exactly the same thing. Do not shove your artifacts, context artifacts, into GitHub. Package manager, NPM, Maven, Gradle, whatever. Repository, registry, Artifactory, Maven Central, NPM registry. 12 years ago, exactly the same thing today. Package manager, context registry. No new technology required, right? And here you might say, you know what? My context is so company specific that I don't want to share it. I don't want it to be on whatever your new Maven Central is. And I will tell you, great, perfect, you shouldn't. Instead, you should do internal distribution. You still need a package manager, you still need a registry, you still need the exact technology that you use for Artifactory for your Java. You need the same thing for your context. And yeah, so I work for the company that does exactly that, but do it in whatever way you like it. The most important part is manage your context as it was an artifact. That's the most important part. Okay? And well, if you didn't copy-paste your instruction from, not into Slack message into your code, don't copy-paste your prompt from Slack message into your agent. Package them once, distribute them properly. Now you might say, okay, how much does it cost? Obviously, adding context to my agent costs money. And AI suddenly, from being very cheap, very fast became very, very expensive. And I have numbers for you. And the numbers are the exact example that I run. The first task was 19 cents. The second task with context, was 27 cents. So adding the context of knowing how to run Kotlin is 8 cents per run. Now, what does it mean? Let's say we have a team of 10 developers that run 50 tasks a day. It's going to be $840 for a month. It means $84 per developer per month. Is it a lot? It is not. Is it not? It really depends on what value this context provides, how much better your agent behaves with the context, and we're going to talk about how you measure that in a minute. Right, so what can we take away from chapter 3? Context is 3 things: skills, rules, scripts. Each has its own lifecycle, each has its own usages, and we package each one in a first class together in the engineering artifact. And we distribute it with a registry, the same that you already distribute all your libraries. Okay, so next we are going to talk about adherence to rules and scripts and skills. Okay, so now we have rules, we have scripts, we have skills. The question is, when do we use what and how? So I have a diagram for you. You have an item that you need to solve. If it requires reasoning, if it requires context-dependent judgment, then it's obviously a skill. If it's always true, always do, or never do behavioral constraint, then it's a rule. If it's a deterministic transformation or check, you have 2 options. You can ask your rule or your skill to run the script. You can say, when you check my email, run this script that goes through my inbox and finds all the messages that are marked as important by Gmail. That's a script that your skill can run. But sometimes there are scripts that your skill won't want to run. Agent might have a motive to skip those. In those scenarios, you use hooks. Now, what are those scenarios? So, we're going to talk about that. Next slide. Okay, so remember how we said don't use prompts, use skills instead? Same idea. Don't use prompts, use rules instead. For a different reason. Rules have much better, well, agents follow rules much better than they follow complicated prompts. For 2 reasons. First, they're much simpler. It's just command, do not delete my database. And the rules are injected on every turn. Every back and forth, the rule is injected into context so it won't get lost. So the adherence is much higher, right? Now, 2 types of rules. The first is to do or not to do. And the second is when you are allowed to do something, you as an agent, when your agent is allowed to do something, or when your agent should actually go and ask permission. Now, obviously, there is some kind of a delicate dance. You wanted to ask permissions for critical things, but you don't want to say yes, continue every time for every action. But this is exactly where we tweak this problem of you're absolutely right. So, comparing scripts to rules. Rules, although the adherence is very good, are still not deterministic. For some reason, your agent might decide not to follow a rule, although it is aware about the rule and knows exactly when, and just decides to ignore it. Scripts, obviously, this can never happen. And you can use those scripts as deterministic checkpoints to work together with rules. And I promised you an explanation about agents that want to avoid doing something. For example, and it's very human of them, there are tests. complicated tests that are failing, maybe flaky, for unknown reason. What human is going to do? What human is going to do? Delete them, comment them out. What agent is going to do? Comment them out, absolutely. Now let's say you have a script that checks that no tests are commented out. And you say to agent, when you build, after your build, or during your build, always run this script. Now agent just did something that this script is going to catch. Will agent run this script? It's not going to do it. But you don't need to have an agent to run your script. You can use hooks. You can use pre-commit, post-commit hooks in Git. You can use your agent hooks. There are different hooks in the tool itself, in the harness, in the CLI, that the agent cannot change from within. And you can use the same scripts twice. You can say the agent run it, and then you can guarantee that it runs it from within. So you will prompt your agent to do something. Your agent will go and see the rules, and then the rule will be delegate the option to script. Now, if for some reason the agent decides not to follow the script will be executed anyway, and then the failure will be returned to agent to iterate over and over again. So this is how we can use scripts to actually enforce even better than we do with rules. Let me show you something else. Or you know what, we are starting to run a little bit short. I will skip this demo. It's basically a hook that prevents it from running something. You can imagine how it goes. Okay, so what should be left to scripts? Exactly what you imagine, right? Stuff like linter, stuff like running tests, stuff like validate JSON schemas, check commit messages, poll CI status, generate code. All those LLMs will do very poorly, scripts will do wonderful, and all we need is to call the scripts from the rules and the skills, and this combination is very powerful. The only problem is, if you will ask an agent, hey, find all the places that you can replace determinism with scripts, it will tell you, I can do everything with scripts. I have this magical tool called regex that I can script everything. And this will obviously be a mistake. Because stuff like natural language parsing is almost impossible to cover completely with regex. This human language parsing is a perfect example when you do need this determinism, and going all the way the other way to actually not doing it with agents is a mistake. So now there is something interesting that happens. We can actually rely on the rules and the scripts to prevent usage of this bias compensation module, which is still broken, as we spoke. But now we are not relying on it anymore. We have rules that will compensate the bias of you're absolutely right, instead of relying on the model itself or the harness itself. So we bypass the thing that doesn't work. We don't care about it anymore. What people say? Well, the agent will just skip the script if it thinks it is no better, and it will do. And the response is, as we spoke about, this is why the scripts run on operator machine or in the cloud, and where in some place that the agent cannot get to it. Okay? So everything that is ministerial is strict, everything constrained is rule, everything requiring judgment is an agent, and when in doubt, err towards deterministic stuff. What else? When the agent have a model to skip a check, it will definitely skip a check. So put this check in a place that it cannot touch. What else? Here you go. You probably know this. grant me power to overcome things that I can overcome, and grant me serenity to embrace things that I cannot change, and wisdom to determine between them. We have the same rule for scripts, rules, and skills. The wisdom to know which is the most complicated part. Okay, now let's talk about how do we know if what we did is right. So, how do we measure if all this, we built a ton of it, actually makes any impact? So, you saw what we had with Kotlin. And it looks better, right? I mean, we know that we want to use the data classes instead of plain Java objects in Kotlin. So it looks like adding context actually helped. But we never measured it. Here it was pretty black and white. But you might say like, well, it looked better. It behaved, we think that it was better. And this is what we call vibes eval. We kind of think that it's fine. But we obviously don't know. And if things change, we don't have a way to actually track it. So what are evals? Evals, short of evaluations, is a way to measure the success of non-deterministic behavior. In our example, we are going to measure the context that we added. There are 3 levels. And you can compare it to the 3 levels of testing of deterministic stuff. The first is we can evaluate a skill. And we can say, hey, there is a skill, there is a piece of context that I add, and I want to compare how the model behaves without this piece of context and with it. And that's your unit test. You can run it on each and every skill. You have your integration test when you actually measure a plugin. Plugin is the context artifact that has scripts and rules and skills together. Obviously, the integration between them will provide what we call a lift. It will improve the behavior, or maybe not, but it's worth capturing the lift of the entire plugin together. And then you can have your system test. You can eval your project, which might have more than one plugin. You might have plugins for Kotlin, and you might have plugins for Java, because in this project you use both. Will they conflict? Maybe. How do you know? You need to measure how your agent behaves with all those plugins together, without those plugins together, and see what is happening. Now, how does eval work? So you have a criteria, and the criteria is what you're going to judge stuff upon. So stuff like immutability, or rule compliance, or correctness. And then there is a judge that looks on how your agent behaved on a particular task and judge it. And it says, okay, it did what the rule said, or no, it actually not really did what the rule said. And this judge can be a human, but it also can be an LLM, right? So we have a bunch of those evals, what we call like an eval suite, and this is a bunch of those criteria that we are going to judge our plugin upon. And what it actually provides us, it provides us with the ability to track regressions. And I'll tell you an example. I had a plugin that gave me an amazing lift, like 4x of improvement. The baseline was 25%. With context, my plugin, the results that I measured were 100%, and I was a very happy camper. And then one day, I ran the same suite, and suddenly, whatever was 100 was about 50. What changed? I didn't change anything. My plugin didn't change. Evals didn't change. What changed was the version of Claude Code that the evaluation ran. It turns out, and you might have heard about it, that Anthropic actually ran for a couple of months on a huge regression in their model. They released 4.7, and it was incompatible with the way they used to run 4.6, but they continue to run it in Claude Code, any of your Claude codes, in exactly the same way. So Claude suddenly got so much stupider for a couple of months, and my regression caught it. And then I went to their issue tracker, and there was like lots of people complaining because they all had evals and knew how to measure, right? So another problem that we catch is rule rot. Rules are changing because there is a new version of whatever we work with that now works differently. How do we know that the rules that we have in our library need to change as well? Again, we have to run evaluations. We have to check that stuff didn't break. Evalcid is our compiler for this matter, and we run our CI to check that it didn't degrade, right? We have versioning, we have changelog, we can see what's happening, and then someone has the ownership to check occasionally that we don't have those regressions, and we have observability. We can actually build a system that will show us that there are regressions right there. And all this process can be built with LLMs. LLMs can generate scenarios for our evals that we obviously need to review, and I will show you an example why we really need to review it. And LLM can also be a judge. It can, probably you want to use another model, but it can say whether what is measured is actually happened or not. And here is an example that I promised you. So I remember our Kotlin tutor. I asked the agent to generate me a scenario, and it did. And the scenario was write a to-do app in Kotlin. And then I had a criteria that also generated by LLM that checked that this to-do app did two things. You could add tasks, and you could mark them as complete. So far, so good. I run it with context, with my plugin, 100%, nailed it. Without context, without my plugin, how much? 100% as well. I paid 8 cents to add knowledge, Kotlin knowledge, and it didn't do a thing. And I was like, okay, that's disturbing. Why adding context actually didn't help? It turns out that I had what we call bleeding. If I test implement to do in Kotlin, any agent will actually go and implement to do in Kotlin. What I want to check is that my plugin adds knowledge or adds practices that are not exist out of the box. Now I switch to implement to do. This looks interesting because if I ask an agent to implement it to do, it will implement it in Python or TypeScript. It will be either or, Python or TypeScript, but definitely not Kotlin. So now we're cooking with fire. Now I can actually say, hey, my plugin added value. Without plugin, it was in Python. Blah, blah, blah. With my plugin, it was great. It was in Kotlin, the future of enterprise AI Java. That was great. Results, with plugin 100%, without plugin 100%. And I'm like, what? Now what? Now the problem is, what do I check? You remember my criteria? What was my criteria? Check that the app, you can add it to do, and you can mark it as complete. So obviously my app in Kotlin does that, but also the app in Python does that. So my eval was still absolutely useless, although I removed the bleeding. Now I can actually do it properly. Scenario, write a to-do app. Criterion, to-do app is written in Kotlin. And I can also judge that it actually works. And now I have 81% lift, 5-time improvement, because without context, although it worked and it got some points on it, it was not written in Kotlin, so it got 20%, right? So now I have my amazing mod 7, not only doing all that and also superseded the bias compensation circuit, but has a harness of eval that can check it backwards compatibility. And we mentioned the observability of the thing. The only reason to have those evals is to actually look at them and know when they are failing. Obviously, evals that degrade because your context rotted is absolutely useless. So you need to have a system that will alert you if something happened with your evals. And again, you can use Tessel, you can use whatever. None of that is our domain or know-how or patented. What I just described to you can be implemented by you, and all it matters is that you actually do that. So you might say, evals are expensive to build and maintain, and I don't have a budget, which again, AI now is suddenly very expensive. You need to run evals, it will cost money because it's all LLM, generated, judged by LLM, and you run plugins to actually run evals. It's a lot of money. But what you need to remember is shifting left is amazing. AI lets you shift left into the negative. With evals, you can know that your app will be written in Kotlin before you actually started to write your app. And your evals can and should obviously go much further than that. You can check, you can guarantee that your agent won't do, or not guarantee, but improve the chances that your agent won't do security, stupid things with security, like SQL injection. Because your agent will have the context of what not to do, and you can check that it actually adheres to this context and won't do it before you write any code. And this is actually saving you money. So, if you are into shift left, this is the ultimate shift left. This is way past humans shift left. And obviously, you cannot measure delta between two versions of your context. You are not engineering, you are waving and vibing, which is very cool. So, evals are fixed scenarios with structured rubrics, not vibes, and regression detection happens on every context change. You need to see it. And guardrails that fail silently are not guardrails at all. So, I think I'm running out of time. Chapter 6 is the summary of all this. You are absolutely right. We can teach our agent to actually respond to us, sir, you appear to be absolutely wrong, sir, and refer a rule in our book. And I have a demo that I don't have time to show, but it actually can salute you when it says you are not right. I won't delete this test because the rules won't allow me, right? And again, I have so many demos. I have a demo of all those 3 problems that I showed you in the beginning that the agent refuses politely, sir, no, sir, to do that because we engineered the context to do that. And that's a placeholder for the amazing demo that I'm going to show. So with that, things to do Monday morning. Yes. Things to do Monday morning are, if you use agents, think about your context. Write a rule, write a script, write a skill, package it as an artifact, and start distributing it as proper context engineering. And if you're not in a position to actually push code, share the link to the show notes with your colleague. And ask your team lead, how do you know that our context is actually doing that? Are we thinking that it's better and we don't really know? We should stop doing vibe evals. And if your agent keep agreeing with you, even when you are wrong, the problem is not the agent. It's what the agent doesn't know and what it has not been told to question. If you want to learn more about context engineering, there is a conference coming up, June 1st and 2nd in London, just here across the 2 hours flight. You can get 50% of the tickets using Baruch 50 as a checkout code. It's going to be amazing. A lot of agentic AI and context engineering right there. And with that, thank you very much. I'm J Baruch everywhere. That's the QR code to the show notes. It has everything, including the demos that unfortunately I didn't have time to show. The slides, the video will be there. And I don't have, questions in Slido, or just shout, I will repeat and answer. I guess we can steal some time. Thank you. No questions.
There was 2 questions on Slido.
Oh, yeah. Can you read them to me, please?
Okay.
Thank you.
It's good to create artifacts, but out of company-wide agent rules. Why should I do it for single repo project-specific rules? Isn't it enough to keep them in repo?
Yeah, that's a great question. Why won't I shove them in my GitHub? And the answer will be exactly the same reason why you won't shove your dependencies in your GitHub. Because versioning sources and versioning artifacts are 2 completely different processes. How do you know which version of skill are you using if you're just checked it out with your code? Does it necessarily mean that the version of your skill have to match the version of your code? What if you want to use another version? How do you do that? GitHub or source control is not a proper place to manage any kind of artifact, including context artifact. Yes?
And the second one, can you show an actual setup to unit test a skill?
Yes, I can show a setup of how to unit test a skill. That was one of the demos that I had to skip. Whoever asked, come to me and I'll show you exactly how it works and how it looks.
And that's all.
And that's all. And that's all. I think we have tea and coffee and good stuff, so thank you again.